Circles and arcs, circles and arcs. We're talking about circles and arcs. A few definitions. First, a circle is going to look like this, and it has a center. And on that center, all the distance from that center to the edge are all the same. That's the radius. Diameter is going to be the distance around. The radius is from the center to the edge of the circle. And the central angle is the angle created from the center with two radius. So this right here would be like a central angle. Congruent circles have congruent radii, and circumference is going to be the distance around the whole shape. Diameter is the distance across the center. When I'm dealing with a circle, and here's my center, a minor arc would be if it's going to create a central angle that's less than 180 degrees. So this right here is in a minor arc. The arc is part of the actual circle. And it is named by two endpoints. So this would be like A, B. And this is how you name that arc, A, B. And this arc is the same degrees as the central angle. A semicircle is when I have my diameter, and it's going to be half of my circle. When you have a semicircle or a major arc, you have to label that with 3 letters. So A, B, C could work. Or C, B, A in this case. C, A, B, because you have to go in order of the circle. And then a major arc would be an arc that's created, but it's greater than 180. So this right here would be a major arc. When you're dealing with a major arc, let's say this is E and this is F. I for sure have to have E and F as my 2 endpoints, because that's where it starts and that's where it ends. However, I have to pick a point in between to tell me the direction. I could pick any of these points. I could pick C, A, or B. It doesn't matter. I'm just going to pick A. So this right here would be a major arc because it's greater than 180. And I have to have 3 endpoints so I know it's a large angle. So here I'm just asking for what are the minor arcs. So minor arcs could be AB because that's less than 180. It also could be BE because that's less than 180. It could also be BED. And it could be AD. Those are all my minor arcs. Semicircles. So here's a line. I could have AE or ADE would be a semicircle. Here's a line. So I could have DEB be a semicircle right here. Here's another semicircle. So that could be ABE. When you're doing these, it can go either way. And my last one that I have is BAD. Bad to the bone. And then I have my major arcs. So looking at my major angles here. So if I look at this picture, I see that if I can create a small angle, the major arc is starting at A, and then it would be going around the long way. So this would be A, D, B. Your 2 endpoints have to be where it ends. Another major arc could be D, A, E. So those are my major arcs. When I'm dealing with measuring, a minor arc is equal to its corresponding central angle. So that means if I have my central angle right here and I know that this right here is 50 degrees, this arc right here is also going to be 50 degrees when I measure it in degrees. A major arc of the related minor arc is subtracted from 360. So if I look at this picture, if I want to know what this arc is, this major arc, I would do 360 minus 50 because I'm getting rid of this minor arc. So this arc would be 310. And a semicircle is always going to be 180. Now you can always add 2 arcs together because that's just like adding 2 angles together to figure out a total arc. So I have to figure out what are my arc measurements. Well, if this central angle is 60, this arc in between the 2 points is also going to be 60, so that's 60 degrees. If I look at SU, this whole arc, well, if I look at this whole angle, that's going to be 80. So this whole arc is also going to be 80 degrees. Now if I look at RST, so I'm first going to draw it out. RST, this arc right here, that's a semicircle, so I know that's going to be 180 degrees. And my last one, if I look at RS, it's just the sky right here. Well, I know this little bit is 20, and I know the whole thing is 180, so I could do 180 minus 20 to get 160 degrees. If you don't remember the circumference of a circle, I would write down this formula. D is diameter, R is radius, pi is your 3.14, and so on. So D is diameter. Remember, that's the whole distance across. R is equal to your radius. That's your half distance across. Either way, you can figure out what the circumference is knowing one or the other. So what if I know the measure of the arc in degrees, but I want to figure out what's the actual length? Again, that's dependent on your radius. Write down both of these equations because I can always figure out what this measure is in actual units, feet, inches, meters, miles, as long as I know the arc measurements, because I take the arc and divide that by 360. And I still use my formula for circumference, so make sure to write both those formulas down. So if I'm looking for the length of CD, what I'm first going to do is find the circumference of the whole circle. So in this case, that would be my diameter times pi, because my diameter is given, which is equal to 28.3 centimeters. But I'm looking for just this arc. Just that arc is 90. So I'm going to take 90, divide by 360, because this is my section that I'm looking for, and times it by my total circumference. And that's going to give me my measurement just for that arc. And my units be 7.1, and I have centimeters. It's talking about length, so I don't have it squared. So right now I want you to figure out what SR and STR, the lengths would be. So this first one would be 100 over 360, because that's my arc length, and my total circumference is 25.1. So that'd be 6.97, or you could round up to 7, and that's feet. My second one would be 260 divided by 360 times 25.1, and I get 18.1 feet. So make sure you took good notes, and have a great day.